Hi, my name is Kirill Gavriluk, and today we're going to talk about best practices of doing mobile push notifications. Throughout this session, we're going to walk through a number of customer stories using a capability we call notification apps as part of our Azure App Service offering that allows you to send push notifications cross-platform at high speed to millions of customers. Push notifications is an essential means to make your app engaging and useful for your consumers, as well as making your app effective at making your employees perform the work they need to perform. Push notifications is used across a variety of industry verticals, from breaking news apps and sport events apps, sending you updates about most recent events, to banking apps sending you account updates, healthcare apps sending you reminders about your prescriptions, or employee apps sending notifications to your employees, updating them on the status of their work items, or alerting them and pointing their attention to something they need to perform right there, right now. Let's remind you quickly how push notifications work. On every operating system, whether it's iOS, whether it's Android or Windows, operating system allows your app to retrieve a device handle. Could be called device token on Apple, or registration ID or on Android, or channel URI on Windows. And that device handle is served to you by a platform-specific notification service. In case of Apple, it's Apple Push Notification Service. In case of Google, it's Google Cloud Messaging Service. Or Microsoft, it's Windows Notification Service. Once you have the device handle that uniquely identifies your app on that device, you can pass it to your application backend. And from there on, your application backend can send a push notification via that corresponding platform notification service to your app on your device. Sending a single push notifications is very straightforward following these steps. So what's so hard about it in real life? In real life, your app is likely need to work on multiple platforms, on iOS, on Android, on macOS, on Windows. So you need to learn how to talk to different protocols to each one of those platform notification services. You need to understand specifics of push notifications for a variety of these platforms. You need to maintain a mapping between the physical device handles and logical groups and logical users. You need to personalize your push notifications and deliver them to users at the time when they expect them, in a form that they expect them to be, in the language that they speak. Finally, you need to often send those notifications at really high volume and an exceptionally low latency, and maintain an accurate registry so you don't send notifications to users that did not want to receive them. Azure Notification Hubs plays a role of intermediary that takes care of all the platform-specific push notification semantics, takes care of aggregating and broadcasting push notifications at high volume to millions of devices, depending on your needs, and mapping your logical users and logical groups of users to physical representations, to physical devices. Let's take a look at some examples and recipes of how to deliver good push notifications. Let's start with consumer apps. Most consumer apps have the same problem when it comes to push. You want to keep it relevant, you want to keep it personalized, and you want to deliver it fast when the user expects it and needs it. Azure Notification Hubs used throughout a number of sports events, including global sports events like Sochi 2014 Olympic Games or World Cup, Soccer World Cup. Many apps use Azure Notification Hubs, even Super Bowl. Those apps serve global audiences, millions of users throughout the globe, and the apps need to deliver notifications to dynamic segments of audience that change all the time depending on individual user preferences. They need to send those updates fast at the time when the events happen. And they need to localize those events and adhere to individual preferences of the users when they send the push notifications. Of course, these apps need to work across all device platforms, whether it's iOS, Android, Windows. And these days, platforms keep coming up. You need to be able to send push notifications to Android devices in China that do not talk to Google Cloud Messaging Service. So you need to use some other ways of delivery. You need to send notifications to Kindle Fire devices, you name it. In case of sport events, architecture typically looks like this. This is actual snapshot of an architecture from Sochi Olympic Games system, in which case typically there is already an existing data platform that serves notification events. It typically sits on premises or in custom data centers of those customers. It doesn't typically run in the cloud, in the public cloud. Those systems receive device registration calls from individual applications and then send them to notification hubs, registering those devices for a number of so-called tags. And tags is a feature of notification hubs that allows you to mark individual devices according to their preferences, according to logical users they belong to, or groups of users. So that could be locations, or it could be username, or it could be everyone interested in Michael Phelps. Let's take a look at how Sochi or other sport events apps implemented push notifications to dynamic audiences. In our case, in your application backend that could sit anywhere in any cloud or on premises, it could be written in PHP, Java, .NET, or Node. You can perform registration of the device, and you can register the device for so-called tags. These are dynamic strings, you don't need to pre-provision them, that reflect what topics, in this case, this device might be interested in. You can also register the device for an optional feature called template and associate this template with the device that allows you to reflect further personalizations, preferences of the user. In our case, our customer speaks Russian, so it expects notification come in Russian, and owns an iPhone, so it expects an iPhone notification in Russian language. So in this case, we have a template that reflects an iOS notification, an alert, and it will substitute at runtime the right message in the right language. So once we register this device for this set of tags and for this and associate this template with it, our backend, whenever the event actually happens, in this case, Michael Phelps wins yet another gold medal, our backend can now send notification to everyone who might be interested either in swimming or United States or Michael Phelps. And we'll pass a message that has parameters, which in our case reflect localized strings. This message is a logical message. It's a JSON structure. And a notification app will take care of identifying which devices to send it to and apply the respective templates reflecting the preferences of individual users owning those respective devices. Notification apps allows you, therefore, to send relevant content to dynamic segments of audience, highly personalized content reflecting user preferences in real time, and send those notifications at a rate of millions of messages per second so that your events, updates get to the users when they expect them to at a relevant time. Another example is closer to home, is Cortana. Cortana is an application that is a first-class app on Windows Phone, and it's recently has been announced that it also will appear on iOS and Android. And Cortana uses notifications in a big way to alert their users about anything they were interested in, or they may be interested in, whether it's flight update notifications sent to individual users, sport news sent to groups of users based on the dynamic interests that Cortana infers, weather updates based on the user locations that can change over time, or just sending broadcasts to large segments of users about recent skills that Cortana acquired that could be interest or relevant to particular users. Same architecture applies. We're using dynamic tags. We're using templates to highly personalized notifications. We're reflecting the dynamic segments of audience like location or topic interests using the tags. And we're sending those events very fast using Azure Notification Hubs to these individual tags or tag expressions. Now, that was consumer apps. Enterprise mobile apps have been growing very fast and utilize push notifications as well. We'll start with a simple example. Here's the Transport for London app. Transport for London is a large enterprise that takes care of London Tube along other transportation means in London. And they needed to offer an app to their employees to enable employees to report assets need repairing. And as part of this app, they need to send push notifications to employees about the status of their alerts, of their logged tasks, as well as any other updates that are relevant. For example, updates around big events or around different events happening within the tube. Notifications need to be sent to enterprise users, to Active Directory users. Notifications should be sent only to legitimate employees. So the users need to be synchronized with Active Directory. Another example of an employee app leveraging push notifications is Skanska, who built an app for construction projects to make sure that the environmental updates in real time can be alerted to employees working on a construction site. In this case, to prevent noise level to exceed limits and affect a nearby neonatal hospital. Same requirements apply. You need to be able to send to corporate users, and only the devices that are currently legitimately owned by corporate users, authenticated corporate users, need to be able to send to groups of Active Directory users. And you need to be able to send those in real time, fast, so that the adverse effects, environmental effects, do not affect nearby facilities like this hospital. Sending to a user, the task itself is fairly straightforward. What we require is application to authenticate the user with the backend. And once we have the user ID that is trusted, we can register the device handle for that user ID. In this case, the user ID becomes a tag in Azure Notification Hubs. What comes next is requirement for sending those notifications securely. You see, in many enterprises, it is not an option to send corporate sensitive data through public cloud services like Apple or Google or even Microsoft Windows Notification Service that offer no SLA or no guarantees about that sensitive data. In this case, with Azure Notification Hubs, you can send a message ID instead. You can send a correlation ID in the actual push notification. And once the client app receives that correlation ID, it is able to pull the data from a service bus queue or from other on-premise secure location that offers the needed SLAs around protecting the data that the enterprise cares about. This pattern is very popular among banks using Azure Notification Hubs or healthcare or governmental agencies. Finally, in the case of enterprise, apps are interconnected. You have many apps that are optimized for individual tasks, but they all serve and listen to shared events. Events can come from sensors and other IoT devices. Events can be coming from Office and other backend systems, your legacy ERP systems, CRM systems. What we recommend is send those events to a service bus. And once they are in the bus, the individual apps can subscribe to the events of one or particular kind and deliver to your apps and devices using a variety of means. It doesn't have to be push notifications. It could be secure push, as we discussed before. It could be in-app messaging, which App Service Mobile features provide using SignalR framework, or could be SMS, which is part of App Service. Finally, I want to talk about yet another peculiar case that is very common among the companies who build apps to be used by their partners or to be used by their customers, by their customer companies. These are multi-tenant apps. You have one app in the store that is used by multiple entities. And in our case, in this example, it's an app close to home. These are a set of Office 365 apps. And they use Azure Notification Hubs to deliver notifications to millions of the users of individual companies buying Office subscriptions. Notification Hubs have taken a good care of representing multi-tenant scenario, since we have a number of ISVs, a number of customers building multi-tenant applications. What we recommend is for your single app that is in the App Store, you create namespaces that reflect geolocations or otherwise stable partitions of your app across the globe. Within each namespace, you can provision programmatically a hub per each tenant. Each hub, therefore, can enjoy isolation and offer you ability to configure tenant-specific settings around delivering push notifications. While all the global settings, for example, push credentials like Apple certificate, could be managed at the namespace level so you don't have to replicate it for every hub. You get a variety of telemetry reports and monitoring at the namespace level, as well as at the individual tenant level, which allows you to manage your application and manage your tenants respectively. We also offer you a number of features that allow further isolation, tenant isolation. For example, control of cross-tenant spamming to prevent from rogue tenants figuring out how to send push notifications to a neighboring tenant and upsetting some of your employees. All of this is provided for you in Azure Notification Hubs. These are the stories of our customers. There are a number of millions of customers sending billions of push notifications weekly through Azure Notification Hubs. And if you need more information about how to implement push notifications at large scale in a secure way for your consumer and enterprise applications, take a look at azure.microsoft.com, follow tutorials, take a look at the blogs, and reach out to us on Twitter. Thank you for your time.